Welcome to Calculus Chapter 4, Section 2. This is Part 2, Implicit Differentiation and Fractional Powers. But we've worked with fractional powers before. That's not going to cause a problem. We got a little bit of some trickiness when we find second derivatives. But finding the first derivative of this, no problem implicitly. In fact, if there was any implicit differentiation type problem that's the easiest to do, that would be a typical problem, it's equations of circles. So implicit differentiation, we're going to take the derivative of both sides. It wouldn't be too inconvenient to solve for y here, but we'd introduce a plus or minus. We'd end up with a plus or minus square root of 1 minus x squared. So then we really have two different formulas for it. Sometimes we might want that, but we're going to go ahead and do this implicitly since it says to. So derivative of x squared with respect to x, 2x, plus derivative of y squared with respect to x. We're treating y like it's a function of x, so that now it's a chain rule. I want the outside derivative, 2 y to the first outside derivative of the inside function times the inside derivative, that's where the dy dx comes from, equals derivative of 1, 0. That's calculus, now it's algebra. Dy dx equals subtract 2x, divide 2y, and I get dy dx is simply just negative x on y. So that is the first derivative. To get the second derivative, I'm going to take the derivative of both sides of this equation. And I get d2y dx squared, that's how we write it, the second derivative of y with respect to x, equals derivative of this guy. Now I could make this negative x times y to the negative first if I didn't care to do quotient rule, but I'm going to do quotient rule. I'm going to put this negative, make sure that's up with the x. Otherwise I could put negative in front of my whole result. Alright, I want low, derivative of high. Derivative of high is negative 1, so I'm just going to make it negative y, minus high, d low, derivative of y is derivative of y with respect to x. All on the square of the thing below. We're going to clean that up just a little bit. I get negative y plus x dy dx is y squared, and we say that's it. But don't forget, this is supposed to end up being like a slope formula, or actually this would be like an acceleration type formula for us. We want to be able to put y and x in and get it. I can't put y a point in and get it because I don't know what to do with dy dx. I wish dy dx wasn't here. I can put up with x's and y's and numbers and things like that, but I can't put up with dy dx. It's like I'm coaching a basketball game, and here's my players that are in the game. I'm happy to have negative y in the game. I'm happy to have x in the game. I'm happy to have y squared in the game. Dy dx is my point guard, and he's stinking up the joint. What would I do? I would substitute for that point guard. Do I have another point guard? I've got another point guard. So substitution, I get negative y plus x in place of dy dx, negative x on y, all on y squared. Calculus, actually calculus was done a long time ago. Algebra, you've been with me for 9 weeks now. What would I do next here? You might say, you might turn this into minus x squared on y. I might. But what do you think I'd do next? I'm going to multiply by y on y. I don't like complex or compound fractions. So I get negative y squared when I distribute to this. I don't distribute the y to this x factor and this. This is all one term. Y cancels y. I get plus negative or minus x squared. All on y cubed. So that is d2y dx squared. Okay. If you're watching at home, this would probably be a really good time to pause and try this problem. But I'm going to go ahead and go through this. So, any questions there, by the way, back on A? All right. So when we find second derivative, you can count on that little substitution step. All right. Very similar. Not a circle. Y squared minus x squared minus 2x. This might be a hyperbola or something like that. But same process. We're going to take the derivative implicitly both sides. So I get 2y times the derivative of y, dy dx. Outside derivative of the inside function, it stays the same to the first, times the inside derivative. The inside derivative is derivative of y. Equals 2x plus 2. Okay? Pretty easy to solve. Dy dx equals 2y plus 2, or 2x plus 2, excuse me, 2x plus 2 on 2y. Can I reduce this 2 with this 2? Of course not. Can I reduce this 2 with this 2? Of course not. Can I reduce the top with the bottom? Yeah. So equals x plus 1 on y. That's dy dx. That's the first half of my problem. But not just the first half of my problem. It says, I got another point guard if the need be. I can put y plus 1 on y in for dy on dx. Probably going to do that later. So second derivative of y with respect to x is going to be derivative of this guy. And again, if you don't like quotient rules, there's so many ways around it. I could make this y quantity x plus 1 times y to the negative first and deal with the chain rule instead if I need to. But I'm going to go ahead and quotient rule this. Low d high, derivative of high is just 1, minus high, how much of minus high? Minus all of high, times derivative low, dy dx, all on the square of the thing below. Low d high minus high d low, all on the square of the thing below. Okay. So I get, at this point, I basically have it. Yeah, I'd get rid of the 1, but then I'd probably be fine. But I'm going to go ahead and substitute in for dy dx. Don't want dy dx there. I'm going to get my substitution y minus, you could distribute this, but I don't think you want to. We're just trying to replace dy dx once, really, times my replacement, x plus 1 on y, all on y squared. At that point, as soon as I get compound fractions, typically I'm just going to clean those up. Multiply by y on y equals y times this guy, y squared, minus. We understand this is one term. This could just as easily be x plus 1 times x plus 1 on y. The y is going to cancel here, and I'm going to get x plus 1 squared. All on y times y squared, y cubed. Now, simplified to the eye of the beholder. I know I could FOIL this. Is foiling this going to do anything worthwhile for me? Nothing here is going to combine with that. Nothing here is going to reduce that by foiling it. In fact, I need to factor, but it still would be no good. So that's where we're at. Okay, now, here's the whole portion of this section that's supposed to be, this is our title here. We've got fractional powers. Big deal, we don't need new rules for fractional powers. The derivative of this, dy dx, which could be called y prime. Now, I'm going to constantly use y prime or dy dx anytime I'm going implicit. Because I just worry about losing track of that prime and it just becoming a plain old y. You can put dy dx here as well. Equals. Bring the 9/4 down in front. X to the reduced by 1. That's 4/4, 5/4. I think that's a great answer. Now, the only thing is, What if the back of the book has that represented differently? I don't think they should, because the convention was established here. We're going to use fractional exponents. But hopefully we all know that this could be 9/4 times some root of x to some power. And I will get people that mix these up, and when you mix things up mathematically, it tells me you don't understand it. At one time you probably had it memorized. When I talk about a fraction, the numerator is what makes the thing bigger. The denominator is what makes it smaller, right? The bigger the denominator is smaller, so the numerator makes it bigger. The denominator makes it smaller. The root's what makes this smaller. The exponent's what makes this bigger. So I could either have x to the 5th in here, or that 5th could be outside of there as well. So the answer might be that. I would suggest it probably shouldn't be. Convention was established. But I just want to make certain when you're looking in the back of the book, you're able to work to their answer. I would say I would expect either of those to be acceptable answers. Okay. So B, I would rather not work with radicals and derivatives. dy dx or y prime equals. Before I do that, I want to call this x to the 1/3. And now I'm going to treat it just like I did the problem above. So I get 1/3 x to the reduced by 1, subtract 1, subtract 3/3, negative 2/3. And I don't think they would have that as our solution. Could be 1 on 3 to the, or 3x to the positive 2/3. And they might have that, but if the convention was established, we want radicals versus exponents, maybe they would have 1 on 3, 3 makes it smaller, 3rd root of x squared. Again, that squared could be in with the x, could be out. So y prime. Probably my favorite answer, and then after that, neither of those conventions were established. We could probably live with those. Again, that is for your checking purposes. Okay. So this one, I do recognize we got a product rule here, but I think I'm going to rewrite this, of course, as x times x squared plus 1 to the 1/2. Sometimes when there's just a simple little x here, we don't think product rule. But this is a function of x times a function of x. This 1/2 is not governing that x. I wouldn't put that 1/2 all the way out in front here. This is a product rule with a chain rule in it. So y prime equals the just plain first function. There's first, there's second. Just plain first, x times derivative of second. All right, that's a chain. 1/2 times the inside function reduced by 1 to the negative 1/2. So that is the outside derivative, or treat the mother function of the inside function. Leave the baby alone, then treat the baby times the inside derivative 2x. Now that's just first times derivative of second. And the big fear is like, okay, I'm done. I knew it was product rule to start with, but I did so much here. But we're only half done. Fortunately, we're done with the hard half. Plus derivative of first 1 times the just plain second, x squared plus 1 to the 1/2. Okay? Equals, definitely you need to clean this up. A number times a number times a number times a number. I can multiply those in any order I want. I'm going to choose 1/2 times 2 is 1, and x times x is x squared. Now, if I'm looking at conventions now, conventions established that we should have square roots. So this would be equals, x squared stays, x squared plus 1, that takes care of the negative. This takes care of the 1/2. And plus square root x squared plus 1. I think that is the best answer based on the question. Y prime or dy dx. Okay, I would rewrite this as, I think you'll follow this, 1 minus x to the 1/2 all to the 1/2. I think that's pretty clear, yes? Okay. I haven't found the derivative, I've just set it up for it. So y prime equals, I've got a mother function, something to the 1/2. So that's 1/2 something to the negative 1/2. Leave the baby function alone, treat the baby, times derivative of 1 is 0. Derivative of this is negative 1/2 x to the negative 1/2. Calculus done, a little bit of algebra ahead. All right. Did I miss anything there? Seems like I missed something. I think I'm good. Okay, so everything is multiplied. Numerator, this guy's going denominator, right? This guy's going denominator. The 1 stay in numerator, the negative 1 stay in numerator. 1 times negative 1 is negative 1. 2's denominator, I'm 4. There's my negative 1/4. This guy's going denominator as a factor. Square root of, that takes care of the half. Denominator takes care of the negative. 1 minus square root of x. Times x to the negative 1/2 to the denominator for the negative underneath the radical for the fraction. Now, because we know square root of 3 times square root of 5, we know we can make that square root of 15, right? So I can do the same thing here. I can say square root of this times square root of that is just this times that. So I could turn this into, I don't know if the back of the book would do this or not, but we need to be able to check and see if our solutions are correct. I could take x and distribute it through and get x minus x root x. It's possible. Possible that's the solution. Is that okay? All right. I am going to stop this video, and I will include this problem because I definitely want you to take some time and try this one on your own. So this will be included on a video right after this one.